we are going to look at the transformation on absolute value graphs. So we have a couple goals today. This is usually an Algebra 2 concept, but our learning goals today is we're going to look at our general template first, and we're going to understand the transformations that are in the general template, where they're going to be and what we're going to do with each one of the numbers in there. Then we have a couple slides that we're going to apply the vertical, horizontal shifts, any stretches and compressions, and then reflections. And then at the end, we're going to do a couple examples that do multiple transformations in one. So our transformation template. Our transformation template has some A's, B's, and C's in here, and those are what our transformations are going to be. So let's start breaking this down. Our first one is, let's look at this A value. This A value is going to be our compression or stretch. Technically, they are called dilations. But what we're going to look at is if A is greater than 1, it's going to stretch this graph. It's going to be taking, and it's going to be like silly putty, where you take a graph and if you pull it up and down, it's going to stretch it and make it skinnier. If this A is between 0 and 1, where it's called a compression. And it's the other way around, where we're going to be pushing this graph and we're going to squash it down, and it's going to be a little bit more of a squished absolute value. Then let's go on to our B value. Our B in here is considered our horizontal shift. Now, because it's inside the absolute value, what we want to know is it's going to be opposite of what it looks like. So if it's positive, we're going to be shifting it to the left. And if it's negative, it's going to be shifted to the right. I know positive should be to the right and negative should be to the left, but because this is an inside transformation, it's going to be opposite. So this B value, we're going to be moving it left and right. Then our C value, this one is going to be, let me kind of arrow through here. The C value is going to be our vertical shift. And we're going to be moving this graph up and down. And when I say moving this graph, what we are talking about, so let me go into the specifics of that, is we should know already that our parent graph for the absolute value function is this graph that I am putting on here right now, where it starts at the origin 1, 1, and both sides of this graph have a slope of 1, 1, and a negative 1 on the left side, meaning that 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and you can create that absolute value graph. This is called your parent function. And these transformations take this parent function and move it left, right, up and down, or either stretch or compress it. Then can't forget about the last one in here, is this negative right there. This negative is our reflection. So if it's negative value in front of your A, it's going to reflect this graph. So if it opens up like a parent does, it's going to flip it around, and this parent function is going to be opening down. So let's go through a couple examples. We're going to go one piece at a time, but this transformation template is just the general idea of what we're up to. So let's first do a vertical shift. What I want you to do, though, every time you do these problems is please, please, please sketch your parent on it so you know what your original function, your parent function is. That is your y is equal to the absolute value of x is your parent. So now we look at this, and this is a plus 5 at the end. So this is your vertical shift. What that's going to do is it's going to take your graph, your parent function, and move it up 5. So what we're going to do is we're going to take our origin point, move it up 5 units, 1, 2, 3, 4, 5. And then we haven't done anything else to it, so all that it does is moves that graph up 5 units, every point on that graph up 5 units. So I've taken it and just shifted it up 5. If that was like a y is equal to the absolute value of x minus 3, that minus 3 is telling me that it's going to go down 3. So we take our parent function, we move our origin 1, 2, 3 down, and that whole graph shifts down 3 units. Okay, so that was your vertical. Now this is our horizontal. We are inside the absolute value. And when I say inside, that shift is affecting our x right away. So I said earlier that it's going to be opposite of what that value is. So this is a minus 3, which means that I'm going to be moving it to the right 3 units. But we always start, always start with your parent. Knowing what your parent function looks like, where it's at, will show a lot easier where you need to shift it to. So now what we're going to do is we're going to move every one of these points right 3. The easiest one to move and go from is taking your origin, moving it right 3, 1, 2, 3, putting it there, and then re-graphing your absolute value. If this was, like again, I always like to do the what ifs. If this was y is equal to the absolute value of x plus, let's say 8, this plus 8 means that I'm going to move it to the left 8. So I'd take my origin, move it 1, 2, 3, 4, 5, 6, 7, 8, and then redraw your parent graph 8 units to the left. So now we got our verticals down, we got our horizontals down. So we've got this one checked off. We got this one checked off. Now let's talk about our dilations, our stretch or compressions. So this is when that value is in front of your absolute value. It is in front of the absolute value. The rule that it goes is if it's this value is greater than 1, it's going to be a stretch. If it is between 1, meaning that it's some sort of fraction, it is going to be a compression. The nice thing about absolute values is your parent function has a slope of 1, 1, 1, 1, 1, 1, 1, and its y is equal to 1 absolute value of x. So this value can kind of be taken as what is the new slope of this absolute value going to be? So if we look at this first one, we have y is equal to 2 absolute value of x. Kind of what that's telling us is this 2 is just going to be the new slope of our absolute value. So if I graph my parent like always, my parent goes here and has a slope of 1 and then a slope of -1 over here. My new slope of 2 absolute value of x is going to still start at the origin but have a slope of 2. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, and then up 2, left 1, up 2, left 1. So I have my positive and negative slope of this new transformation. So in the other direction, I guess we can look at y is equal to 1/3 absolute value of x. This one, we can consider this our new slope. And so it still starts at the origin, but instead of going 1, 1 as our parent, it's going to go 1, slope of rise over run 1, 3, 1, 3, 1, 3. In the positive direction, 1, 3 in the negative direction, 1, 3. And that confirms our idea of, in the red, it was a stretch because this was 2, so it looks like we've taken the parent and kind of stretched it out, pulled it up. And then in the blue situation, it was a fraction, so it's like we compressed that parent function down towards the axis. That's why they're called stretches and compressions. Then lastly, we're just going to focus on just this negative in front. If your parent function opens up, if it's a negative, you're going to take and you're going to reflect that across the x-axis. And so instead of opening it up, it'll have the same origin, but it will open down. And that's where that negative comes in. So let's put all this together. Let's do 2 examples to put it all together. So let's go through here. Let's identify first all the transformations. This 2 is a stretch of 2. We can think of it now as my new slope. This 4 is plus 4 because it's inside, means that we're going to be moving it to left 4. It's going to go in that direction, opposite. And then this minus 3 is my vertical, so that is going to be down 3. So I always put the parent function on here. So I'm going to put the parent real quick. Okay, now let's apply our shifts first. So let's get to where this new origin is going to be. I'm going to go to the left 4. 1, 2, 3, 4. And then I'm going to go down 3. 1, 2, 3. So at that spot right there, this point right here is where this new function is going to originate. Now from that original point, we do our stretch of 2. So from this origin point right here, we're going to go up 1, 2, left 1, and do a slope of 2. Do it in the other direction. And that is where our new absolute value transformation is going to be. Last one. Let's look at this one. Oh, all right. We have in the front It's negative 1/2. It's negative, so it's going to be a reflection. And then it's going to be 1/2, so it's going to be a compression. Now, I don't have anything inside this x. This x is by itself. This x is all by itself. So I have no horizontal shifts. But I do have at the end a -3, so that would be a down 3. So my parent, always right here, starts at the origin, slope in both directions of 1 and -1. So let's move it first. So we're going to move it down 3. 1, 2, 3. So our new spot is going to be, our new origin is there. So now we need to reflect it and do a slope. So it's going to open down like this, but it's going to be 1, 2, 1, 2, 1, 2, 1, 2 in both directions. So I go slope down 1, right 2, down 1, right 2, down 1, right, left 2, down 1, left 2, and I still have that V of an absolute value, but it is reflected and has a new slope of 1/2.